All right, who's good at PowerPoint? Who knows how to turn off the preview slide? I want to get rid of that. Let's see.
I think if you go in there, I'm just guessing. One in here, and then I think display settings.
Aha. You got it. Thank you. All right, all right. Okay, all right. Rion's to the rescue. Okay, all right. Well, I appreciate everybody coming tonight. We got a pretty small group, but that's okay. We're going to be following on with the discussions that we've been having for I guess since the beginning of the semester, with looking at sort of the classical arguments for God's existence. And so tonight we've kind of lumped a couple of different topics together because we had trouble getting all of it in a 16-week semester. So I've tried to put together, this is kind of a blending of several talks I've given in the past that talk about teleological argument, the design argument, and the fine-tuning argument. So they're all kind of mishmashed together. I've put it together in a way that at least the way I'm going to present it should, I hope, kind of lay out each of the ideas. There is some overlap between the ideas. They're not mutually exclusive, but we are going to try to cover several different ideas with this presentation, again, just in the interest of time. And so we're going to look tonight at this idea. It really centers around design. We're going to look at the nature of design and whether or not the universe appears to be designed for a purpose. Now, when we talk about the universe, we're talking about everything in the universe. We're talking about everything from the simplest of atoms all the way up to the most complex galaxies and everything in between. So all material, physical reality, that would include humans, animals, any life form, even non-life, like the hydrogen atom, right? Molecular life, chemical life, astronomical structures, subatomic structures. Do we see the evidence of design in the world around us? And that's kind of the approach we're going to look at. So we're going to start and look at all of the different levels of reality, and we're going to try to take a look and see, do we observe design? And if so, what could best explain design in the universe, in the world and that we live in today? So it's usually good when you do this to try to define your terms, right? So when we talk about design, if you take the definition, the classical definition, you see some pretty familiar words that go with this concept of design. You see preparing things, planning things, structure, form, purposeful, skillful, purposeful, conceived, intentional. You'll even see a definition that talks about conceived in the mind, which is kind of interesting, meaning that whenever you see something that appears to have the attributes of intelligence in it, that's usually, not always, but usually a good sign of some type of intentional, purposeful, skillful, planned, ordered design to that thing, whatever that thing is. And they give some pretty interesting examples here, designing a bridge and, designing a scholarship for students, right? So but you see, these are kind of the sort of the primary attributes of what we would consider something to be designed, intentionally conceived or purposefully done, planned and executed. So as we go through this, kind of think of these words. Think of these, I kind of just extracted them here. Think of the words, kind of remember those words: purposeful, intentional, artistic, skillful, because those are going to be, we're going to look for those attributes in the things that we're going to investigate, right? And if you see that, then that could be a sign that maybe there's some intentionality, some design, some purpose behind these things that we're looking at. So we're going to try to go through and look at many different levels of existence in the natural world. We're going to start with like the subatomic and the atomic level. We're going to go to the cellular, the subcellular, the cellular. We're going to look at organic life. We're going to look at astronomical bodies and entities, you know, galaxies, stars, planets, solar systems. So we're going to try to look at all levels of existence, all, you know, from the smallest to the largest and everything in between. And we're going to say, okay, do any of these things appear to have the words that we had a moment ago: purposeful, intentional, deliberate, planned, ordered, structured, form? Do any of these things seem to exhibit those characteristics, right? Because if we see that, then that maybe there's some evidence that there's something going on here that we want to investigate. So we're going to look at that. We're going to look at each one of those, and we're going to try to figure out, is there design in these things? So, okay, so it's probably the easiest to start with the thing that gives most students nightmares and headaches, the periodic table. This is also the chart of nuclides. You may be less familiar with that, but that is all of the list, and it's much larger than this. This is just a tiny little fraction of it. But these are the empirical form or structure for chemical elements. These are the stable elements, right? These are the ones that are, the nucleus is stable, and these are all the ones that are unstable or radioactive, except for the ones on the blue diagonal. And so when you look at the periodic table of elements, that's probably the one that's more familiar to most of you. Do you notice form, pattern, or structure? Do you notice things in a certain place for a certain reason? Now, I don't know if we have any chemistry folks in here, but what is the form, pattern, or structure to the periodic table? Like, why does it look like this? Why does it look this way? Why did the people who discovered these elements years ago, why did they arrange them in this way? Anybody have an idea about that? Or, yeah. Okay, certainly size of the atom. What about anything with the valence electrons? Anything important there? What do you think? Yep.
How it will combine with the other.
Yeah, right. And so you got different valence electrons. Obviously, the lighter elements are near the top, the heavier ones are near the bottom, right? So you see a pattern here. Now, there's some interesting stories that I won't go into much depth here on this, but as they were discovering these elements in the 1700s and 1800s, right? There were some that didn't get discovered until like somewhat recently, like the last 50, 100 years. As they were discovering these things and they were assembling this thing we now call the periodic table, there were a few places that were missing. There were a couple of spots here that they hadn't discovered yet, but they kind of knew that there had to be an element that fit in these locations because they saw the pattern of the periodic table. And sure enough, as time went on, they would discover, you know, cesium, right, or platinum or lead, and they would discover it and say, aha, there it is, that's the missing one, because it has a certain number of valence electrons, it has an atomic mass of this, an atomic weight of that. And so they kind of knew as they were assembling the periodic table that they were going to eventually fill out this form, pattern, or structure. And indeed they did. In fact, now we have a complete periodic table. Of course, the really heavy elements that are out here, they keep trying to create new ones artificially, right? Which is always interesting. But it does appear that there's a pattern to this. It's not just that the people who put it together decided to make it this way. This pattern was already there. And as they discovered elements, they started putting the puzzle together. And they said, oh, wait a minute, this one goes here, this one goes here. Oh, look at that. There's a pattern here, there's a structure, there's a form. It appears to be organized or ordered. The same thing with the chart of the nuclides, which again is much more comprehensive, much more extensive. For every element here, for every element you have here, it's almost like a three-dimensional plot. Imagine this in 3 dimensions going in and out of the wall. There are isotopes of every one of these that are radioactive, both with more neutrons or more protons in the nucleus. So imagine this coming out, and for every one of these, there are multiple radioactive versions, isotopes of each one of these. These are the stable ones, but there are radioactive versions of every one of these, dozens and dozens. I mean, and when you put it together, there are thousands of elements. But interestingly enough, you can put it on a pattern. You can put it on a form. There's structure to it. It's ordered. The way in which it goes together fits. And so it seems like there is some type of pattern going on here with the way it's structured. It isn't just that a bunch of smart people got together and decided to make it look this way. It already had this structure, and as they discovered the elements, they were putting them in the places where they needed to be and found the pattern that was there. Okay, what about at the subcellular level? Like DNA, for example, right? When you look at DNA, you've got 4 basic letters, right? You've got adenine, thymine, guanine, cytosine. You've got many combinations of those letters. You can form many different genetic words or, DNA structure. It contains both syntactic and semantic information. It appears to have information built into it that has meaning or purpose. When you look at this, nobody would say that this was something caused by natural forces, right? I don't think anyone would say this was created by natural forces. It's composed of 8 letters, 3 words, and it has a meaning. It contains syntactic and semantic information. So if something with 8 letters and 3 words is clearly created by an intelligent agent, wouldn't something with 3 billion pieces of coded genetic information, couldn't that possibly be intentionally made as well? I mean, nobody would say this was just an act of a random act of nature, and that's only 8 letters and 3 words. And here's billions of pieces of genetic information with incredible specificity and complexity that controls every part of our biological makeup, our color of our eyes, color of our hair, how tall we are, how short we are. Everything about us is contained in these billions of pieces of genetically coded information. So it kind of looks like if we're willing to accept this as something that was designed or intended for a purpose, maybe this is something that was intended for a purpose, because it's way more complicated than this, that's for sure. And nobody would say this was just a random act of natural forces. Interesting, right? Interesting to look at. Okay, well, all right, maybe you're not convinced. Okay, well, what about cells? Cells are really cool things. Cells are like really simple at first, it would appear, but yet they have a lot of complexity to them, right? You've got a nucleus, you got mitochondria, you got a cell wall, you got lysosomes. When you look at a large-scale factory, it is controlled and contains all kinds of individual components and pieces that work together for a purpose. In this case, they're manufacturing some big steel pipes, it looks like. So manufacturing centers, production centers, they have a control center, they have a power plant, there's a building structure. It's created for a purpose. Well, that's interesting because an amoeba also seems to have those kind of things. It has a control center, it has a power plant, it has a structure, it has a cleanup system. Nobody would say this just randomly came together from a tornado without a purpose. But yet it looks kind of like this. It has all the same elements. And we would say this is clearly designed for a purpose. Maybe this is designed for a purpose. Maybe this has the attributes of design, just like this clearly has the attributes of design. I don't know, maybe. All right, well, what else? What else can we talk about? What about organic level? What about humans and dogs and cats and animals and lions and tigers and bears? Let's look at just humans, but again, some of this would apply to any living creatures. Do humans possess the attributes of design? I don't know. How would you know? Well, when we go back to the original definition, there was intentionality, there was purposefulness, there was, I think some of the words were artistic and skillful, right, was one of the words for design. When you look at humans, you see some interesting attributes, right, that might point to design. Sentience, free will, the ability to abstract and understand universals, even the ability to recognize beauty, like art and poetry and music. That's kind of an interesting one. Like, what's the survival advantage of that? Like, who cares if you like the Mona Lisa or Mozart? Doesn't seem to give you any survival advantage, but yet we seem to recognize beauty and value, things that are designed for a purpose, intentional, deliberate. We have I didn't put it on here, but creativity is a very important human attribute, right? We recognize design, we recognize these things. So maybe there's something here. Maybe there's something about humans that seems to point to design as well, right? Beyond just natural selection, because there are a lot of things here that would be somewhat hard to explain. I mean, the desire to self-sacrifice doesn't seem like that would necessarily be something that would seem to be something that involves a choice, right? That would be sentience or free will, right? That would be something willfully chosen to do. That seems to require, volition, choice, design, right? Purposefulness, intentionality is one of our words for design, right? So again, when you look at it, it's kind of interesting. All right. So what about the universe itself? What about the solar system and all the planets and stars? And if we just consider just our own solar system for a moment, but of course this would apply for anywhere in the universe. But let's look at our own solar system. What you notice is there are an incredible number of very delicately balanced and very finely tuned attributes of the Earth that make it fascinatingly perfect for the sustaining human life. The distance from the Earth to the moon, the rate of the universe's expansion, all these things are very, very precisely balanced to be able to permit life on Earth. Human life. None of the other planets have this. And it does kind of look like there's some intentionality here. All of these, in fact, I only listed about a dozen. There's actually over 200 things. There's actually a list of over 200 quantities when you look at it that are amazingly fine-tuned and balanced to be able to permit life on Earth. Yeah.
Not life on other planets because of like like creation story.
Yep.
But if we're trying to take a step back and look at it in a different way, do you think that there's just not life in those other planets because it's like they're meant?
Yeah, it's hard to say. The human life would require this degree of fine-tuning for the planet that you're living on, as far as we can tell. Now, there may be other life forms that don't require that, so can't speak to those. Certainly possible that there could be other life forms that are not human. Perhaps there's like a planet where algae exists, and maybe you don't need all of these finely tuned things because maybe they don't need as much oxygen as we do or as much daylight as we do. So certainly it's possible that life could be on other planets. But when you talk about human life, yeah, that is pretty astonishing to look at, all the things that are needed. There could be other planets with this, but we've not found them yet. And they could be out there, but we don't know. We don't know. It's a good question. We're not sure. But what we do know is that it seems like things are pretty finely balanced and tuned for human life here on Earth, good old Earth. And so it does make you wonder, that's quite a coincidence when you're talking over 200 of these quantities that just happen to all be right in that very narrow life permitting range. Again, not proof, but certainly worth thinking about, right? Certainly worth considering. Okay, so believe it or not, we're not the only people to ever think these things. I know that's shocking, perhaps. But our friend Isaac Newton actually had some ideas about this back in the Renaissance, the late Middle Ages, early Renaissance. And he said, look, I think we can all agree that everything that is designed, every complex design has a designer. He thought the universe appeared to be designed, again, when looking at multiple levels of the universe, not just stars and planets. And so he concluded, therefore, the universe must have had a designer, right? This is where we get the idea of the teleological argument. Teleos, the Greek word for goal-directed or purposeful, intentional, designed, telos. So this would be sort of the formal understanding of the teleological argument. The fact that there appears to be some design when we look at all aspects of the universe. Now, again, we're not just talking subatomic or atomic or astronomical. We're talking everything. At every layer, at every level of existence, there does appear to be some type of designed or purposeful structure or form that's put in, that is part of our universe. And so this would be the teleological argument or the teleological approach. And Isaac Newton thought, okay, this based on what he knew, this seemed to make some sense. Now, of course, one of the other things that's important to keep in mind is that along with this is something known as the anthropic principle. And it's a concept, or it's an idea. Anthros, like anthropology, right, is humans or mankind or humankind. So the anthropic principle, a methodological principle that says that the universe seems to be structured in a way that allows for the existence of life and is perceivable by intelligent agents. Right? That when you look at the universe, everything from subatomic particles all the way to galaxies, there appears to be order and structure and form and pattern, and we as intelligent agents recognize that. It's not totally random. We see order and form and structure and pattern, and because we're intelligent agents, at least we like to think we are, and we're rational agents, we recognize this. And so the anthropic principle really points to the fact that the universe seems to be created in a way that's perceivable and understandable by humans, by rational agents like us, by humanity, by mankind or humankind. So the anthropic principle would say, okay, maybe there is something to this, because whatever created all of this perhaps also created this to perceive and understand all of this, because they were created in the same way from the same agent. It wasn't like this was created by some process and this was created some other way, and this agent can't recognize any of this. No, we recognize it at all levels of the universe, right? So there seems to be something that's happening here that that's worth considering. Now, when you look at design and when you look at intelligent versus natural causes, I would like to think that we can tell the difference between something that is made by an intelligent agent and something that's made by blind forces of nature. It would seem like we could tell the difference between those two. Nobody would say this was created by wind and rain and sleet and snow and hail, and nobody would say that this was created by Native Americans. I mean, it's just not reasonable. Clearly, this was made intentionally, purposefully, skillfully, with a goal and a purpose, and this was made by natural forces. Now, both are very majestic and beautiful, but you can kind of tell the difference between things that are natural and things that are made by an intelligent agent. At least we like to think we can. So that is kind of the way we figure out design, if there's design in the universe. Okay, so let's look. Do we see this? Well, let's just do a simple illustration. We can start with, the smallest, or one of the smallest things that we know about, an atom. This is actually a hydrogen atom. So there's the proton, and that's the electron cloud going around. And when you look at elements that we see, like, again, the simplest one is hydrogen, we see order, we see structure, we see predictable behavior. It's governed by laws of quantum mechanics and electrodynamics. And when we look at, let's say, the Milky Way galaxy, here it is, almost infinitely larger, we kind of see the same thing. We see order, we see structure, we see it's predictable, it's governed by, in this case, the laws of gravity. Okay. Maybe there's something here with design of the universe, design of structure that shows some similarities. Now, of course, obviously there can be objections to this. Is it possible that something could appear to be designed for a purpose, but not actually be designed for a purpose? So is it possible that nature could fake us out and create something that appears to be designed, but really it's not designed by an intelligent agent or an intelligent with an intelligent, purposeful goal? Well, it is actually. And so we have to consider the possibility that, yeah, it's possible that there could be some ways of achieving what appears to be design, even though it wasn't designed for a purpose. Some would say that perhaps there have been an infinite number of universes that have existed. And so the fact that everything appears to be designed and ordered really isn't a coincidence, because there's been a nearly infinite number of universes, and eventually the one we live in would have come into existence. And so that would explain how we got here. Of course, there are some problems with that approach. It doesn't solve the need for a designer necessarily, because it seems to multiply the need for a designer, because now you have to postulate an nearly infinite number of universes just existing rather than just one really complex universe. So that does present some problems. The other thing is, it really almost anything can be explained away, right? I mean, you can explain away literally anything with the idea that there's an infinite number of universes. So it does make you wonder whether or not that's really a valid explanation if practically anything can be explained away with it. There has to be some limitations with your explanation. And replacing an unobservable creator with unobservable multiple universes doesn't really seem to solve the problem, right? Because we're kind of right back where we started again. So again, it's not impossible, but it is certainly worth considering that, maybe there are other explanations rather than just design, intentional design. Okay. There's also some problems with the law of causality, right? Because I think we would all trust the law of causality, and we would all say that it does, the law of cause and effect, right? The law of causality. So look, I mean, if we don't need a cause, or if we're going to postulate a creator like God, and God doesn't need a cause, then why does the universe need a cause? Maybe the universe just exists, and that's it, right? And it's always existed. Although now, today, there's a lot of evidence that would point against that, because there seems to be a lot of compelling scientific evidence that the universe did come into existence at a time and place in space in the past. It is certainly possible that the universe has no explanation for its cause. But again, there are still some trouble with that, because how does something come into existence without a cause? That's difficult, because that would violate the law of causality. I think the way a Christian or a way a theist would answer it was to say, well, God didn't come into existence, God just exists. And you could say, well, the universe just exists. But the scientific evidence would say, no, the universe hasn't always existed. The scientific evidence would say the universe came into existence at some point in the past, some 13 billion years ago, which would seem to point to a cause, which would seem to point to a creator of some kind, something that initiated it. And so it's entirely possible that some causes are not physical. Not all causes have to be physical, right? Non-physical, non-material things can cause physical things to happen. So if you've ever had an experience where you were angry or depressed, those emotions that you're feeling, which are producing the chemicals in your body that are making you respond the way you are, those ideas are not physical, but yet they're causing physical effects on your body, on your mind. on your physical being. So it's possible that not all causes have to be physical. Some can be non-physical. Things like ideas or thoughts could be non-physical, but yet they could cause a physical change or a physical response in some way. So it's entirely possible that you could have something that's a non-physical response. So it's important when we look at the design inference to be very careful to say, look, there are a lot of things to consider when looking at the existence of God. Not all of them are based on design. Not all of them are inferred from design. So even if you were to eliminate all of the arguments that considered design or intentionality for a creator, you would still be left with quite a few arguments for God's existence that don't involve a design or intentionality. And so while it's not a slam dunk that design proves God's existence, it is one of a number of different lines of argumentation that seem to point to a creator. It's not in and of itself the only one, but it is one of quite a few. And of course, if you're a Christian, you also have lots of other good evidence on your side, because there are a lot of other things that would point to Christianity and the existence of the Christian God that could also be used as evidence. And I think we've covered some of these in our classes here this semester: reliability of the New Testament, the resurrection, fulfilled prophecies, miracles. So again, you've got a lot of things that you can point to that have nothing to do with design, that have nothing to do with the teleological argument or the fine-tuning argument. So design isn't the only line of argumentation you can make. It's certainly one, but it's not the only one. You have a lot of other evidences here. So we like to look at it then in this way, and we like to say, well, okay, we acknowledge that it's not a slam dunk. We acknowledge design is not a slam dunk to prove God's existence. But we don't need 100% certainty. All we need is something that is beyond a reasonable doubt. And we would say, if you modify the argument and say, look, as verified by the anthropic principle, we would say beyond a reasonable doubt, the universe does appear to be designed for a purpose. It's not 100% certain, but it appears to meet the criteria of beyond a reasonable doubt. And we're not the only ones to think this. There have been some pretty smart people in history who also felt this way based on their observations. Kepler, maybe even more so than Newton, was one of the more famous ones. The laws of nature are within our grasp, the grasp of the human mind. God wanted us to recognize them by creating us in his image so that we could share in his own thoughts. Pretty neat, right? And so they recognize that, okay, again, this is kind of along the lines of the anthropic principle, but we recognize we're intelligent agents. We recognize that we understand what design is because we can design and create things. We see design in nature, even though we necessarily can't explain it with certainty. It does appear to have the telltale signs of something that was created with a purpose, an intelligent, purposeful, artistic, skillful agent. And we would say that would be God. We would say that could very well, beyond a reasonable doubt, could be the designer of what we have today, what we live with today in our universe, in our world. Again, not at 100% certain, but at least beyond a reasonable doubt. Now, there's another set of arguments that kind of go along with this, and this is where I kind of merged some things together. There are also an amazing number of physical constants in the universe. Now, these are scientific mathematical constants, okay? These are not actual objects. It's not like a star or a planet. These are measured, observed physical constants that describe nature. These are constants that we observe that are not determined by the laws of nature. In fact, just the opposite. they determine the way nature is. They determine the structure of nature. They can't be calculated from first principles. So, for example, the acceleration due to gravity is a first principle truth. It's not something that can be derived from everything else or anything else. The rest mass of an electron is what it is. It can't be derived from anything else. It is a first principle truth. It is something that is what we would call self-evident or foundational truth. Well, guess what? There are lots and lots of these things. And even secular scientists are kind of blown away by this. So if you go into the back of any chemistry or physics textbook, you will find pages and pages and pages and pages of these physical constants. And I'm not joking when I say there are literally hundreds and hundreds and hundreds of these observed physical constants. The mass of a proton, Planck's constant. I mean, Faraday's constant, Avogadro's number. Ooh, there's a chemistry nightmare for you. The Boltzmann constant. All of and I've just listed one page of it because it's just, I can't list 40 pages. But every one of these is fixed, unchanging, and not governed or determined by the laws of nature. And in fact, if any one of these were to change even by the slightest amount, it's very likely we wouldn't even have a universe to live in. Like, for example, if the rest mass of a proton were slightly higher, or the mass of a neutron were slightly smaller, no stars would ever form. We would have nothing in the universe. The universe would have never come into existence. And every one of these is balanced and tuned in an incredibly precise way, but yet none of these constants are created by nature. They describe nature, but they're not a function of nature. How is that possible? Like, how is that actually possible? Unless there was some intentionality here. We're not talking like two constants. We're talking hundreds and hundreds and hundreds of constants that are all finely tuned and precisely balanced to be exactly what they are. And a change in any one of them would make the universe either uninhabitable or non-existent at all. In most cases, it would make the universe not even capable of existing. It certainly wouldn't make it conducive for human life, that's for sure. But in most cases, the universe wouldn't even exist. This is an interesting question. How did it get this way? Even Stephen Hawking was amazed. The remarkable fact is that the values of these numbers seem to have been very finely tuned to make possible the development of life. And I'll even go one step further, to make possible the existence of our universe at all, let alone life, right? Because you need a universe first before you can get life, right? Even if you have a universe, it doesn't mean you're going to have life. You could have a universe with no life in it. But it is astonishing. Very, very narrow life permitting range, and I would even say existence permitting range. One of the other things that scientists have found out is that a change in one parameter, like for example, a change in one of these would affect the other one. Like if somehow we could change the rest mass of an electron, let's just say we could do that, well, guess what? The magnetic flux constant is going to change, and the quantum constant is going to change. So they're all linked together and delicately balanced. It's just astonishing to see. How is this possible? The speed of light, c, shows up everywhere. I don't know if you noticed that, right? Speed of light shows up everywhere. If that were different by a fraction of a percent, almost every one of these constants would be affected in some way, shape, or form. But yet there it is, perfectly at the value it needs to be at. So it's interesting. It's interesting to ask the question, is this finely tuned for a purpose? Even, this is as recent as 2018, 2019. These are articles we found about the strong nuclear force, the weak nuclear force, the electromagnetic force, gravity. Had any of them been different, And again, these is from physics. These are science articles, right? Interesting. The force is super strong with quarks. How is it so delicately balanced? How is it so precisely aligned and perfectly balanced? And so, yes, even secular scientists are like, this is interesting. There's something going on here, because it's not just a random, it's hard to see this as just being a random combination of effects. Here's the expansion rate of the universe, Einstein's equation. This is the cosmological constant, right? This describes the expansion rate of our universe. If that cosmological constant were off by 1 part in 10 to the 120th power, the universe would not exist. Now, to put that in context, you've got about 10 to the 14th cells in your body, and there have been about 10 to the 20th seconds that have elapsed since the beginning of the universe. That's how big 10 to the 120th is. So all it would take is a change of 1 part in 10 to the 120th of the cosmological constant, and no universe would exist. That's how precisely balanced it is. It's fascinating to consider that this could be a sign of something that was intentionally made this way for a purpose, for life to exist, for the universe to exist. And if you look at the 4 fundamental forces, and I won't go through all these because I don't want to take up too much time, but again, these are some of the things that would happen if gravity were a little different, if the strong nuclear force were a little different, if the weak nuclear force were a little different, if the electromagnetic force was a little different. It's just complete chaos if any of these things were just slightly different. If the strong nuclear force were slightly larger, you'd have no fusion reaction. You'd have no suns. You'd have no stars. We'd have no sun. If the gravity were slightly bigger or smaller, the Earth and the moon would be too far or too close to one another. It would completely destroy life on Earth. The sun would collapse or possibly expand, depending on which way gravity goes. The electromagnetic force is really responsible for the number of elements that we have in our solar system. We wouldn't have any hydrogen. We wouldn't have water. We wouldn't have a sun. I mean, any one of these that could change the 4 fundamental forces of nature would completely annihilate life, and in most cases annihilate the universe itself. It wouldn't even exist. And so again, it's worth considering. So what best explains all of this? What best explains all this? Well, when you come down to it, there's really only 3 choices, right? Either this amazing fine-tuning is either due to physical necessity, meaning it had to be that way. There's no other way it could be. It just had to be that way. Chance, we just got really, really lucky, and it just happened that all those things work out together, or it was made that way for a purpose. It was designed. Now, we would argue that the fine-tuning does not appear to be physically necessary, and although it could have happened by chance, the odds are almost astronomical against it. And so we would conclude that it's got to be designed as an inference to the best explanation beyond a reasonable doubt. Now, why can't it be physical necessity? Why can't the answer be it has to be this way? It couldn't be any other way. Well, actually, what we observe is that the chances of a life-permitting universe not existing are actually much, much, much higher than a life-permitting universe existing. In fact, scientists are astonished that we even have a universe at all when you look at what it takes to get a universe to work and function. There's no reason to think that it had to be this way. In fact, if anything, it's astonishing that it even exists in the first place. There's almost no reason that it has to be this way because of all the things that need to happen to get it this way. But there are people who try to explain that it has to be this way, that the universe must be this way, sort of reasoning from effect to cause. Because we are here, it had to have been this way because we're here. Well, they've tried. I mean, they have definitely tried looking at different types of grand unified theories, the grand theory of everything. But at the end of the day, the conclusion always seems to come back that there does not seem to be any evidence that a life-permitting universe is necessary. Now, it can happen. Of course, we are here, so it did happen. But there's nothing to say that it must be this way. And in fact, in most cases, and most conclusions are, it really shouldn't even be this way, but it is. And so no evidence has been found to say it must be life-permitting. We have to be here. There's no other answer. But yet, they are continuing to look to see, is there a single unifying theory for all forces of nature, right? That's what physicists and scientists are looking to do. String theory, M theory, a grand unified theory of everything. Maybe that would explain that we have to be here, that the universe had to be this way. But no such luck yet. There's also a unified theory of everything, which would include all fields, not just physics, biology, chemistry, math, all of them, which is even more, aggressive, even more astounding that there could be a grand unified theory of everything. That might even include the physical and the metaphysical. Who knows? It's possible. But again, all evidence would seem to point to the fact that there's nothing that would say that it's required that we have a life-permitting universe. Of course, we've talked about chances, and we talked about maybe we just got really, really, really lucky. And some would say, well, we don't need an explanation because we're here, so, and maybe there's the many worlds hypothesis, and no explanations needed, and maybe we won the cosmic lottery. But again, when we look at the numbers and you look at the probabilities, it is vanishingly, vanishingly small that it was by chance. Even with the many worlds hypothesis, it's still a very long putt. And that's if you can explain the many world hypothesis, for which there is no evidence that we're aware of right now. The many universes or many worlds hypothesis. So the odds that we're here just simply by chance are really almost incomprehensibly small. Again, not zero. We acknowledge it's possible. It's certainly possible. But well out of reach, certainly not achieving beyond a reasonable doubt, we would say. And look, we're not the only ones to think this or to realize this. There have been a number of physicists and scientists who basically said, look, you just got to look at the data. You got to look at the facts and just ask yourself some basic questions. There seems to be something going on behind it all. It's just so astonishingly unlikely. And the impression of design appears to be just overwhelming. Again, when we understand the concept of design, when we understand the idea of design. And so many scientists today, even those that are not of a religious or theological perspective, they even admit, yeah, this is hard to explain short of a designer, short of a creator. This is kind of difficult to rationalize away by chance or by necessity. It's very difficult to kind of rationalize this away. The impression of design does appear to be quite overwhelming for them. And in fact, as Christians, as believers, I think we could say, yes, we can acknowledge that there is design and intentionality in the universe. Okay, how did I do on time? Not too bad. We'll try to keep it at an hour. All right, what questions do you have? Any questions or any comments? Mm-hmm. I think that's an electromagnetic microscope, an EM microscope, I think. Pretty sure that's an electromagnetic microscope image. Yeah, that's yeah. So, yeah, pretty neat. What are there, any questions or any comments?
Do you think that it can also be by chance, but it's like a little bit of both? So like a creator that knows a thing,
Yep.
knows that it,
Right.
but then there's also chance in it. But then that is kind of
Yeah. One of the things about chance that's difficult is, and I know this is going to sound strange when I say it, it's not really a thing. When you think about it, it's not really a thing. Right? I mean, it happened by chance. Well, what does that mean? It's not a causal explanation. Like, for example, my wife and I got in a car accident about a month and a half ago. And the timing was amazing. I just happened to enter the intersection at the exact time that this guy was coming into the intersection, and we didn't see each other. What are the chances of that? Pretty low, but it happened. But is chance the explanation? Is that the reason we had an accident? No. Chance is not a causal factor. It doesn't describe anything. If you think about it, it's really not an explanation for things. It's kind of the absence of an explanation, actually. So it's hard to think of chance as explaining something because it's not really a thing in an ontological sense. And so you're kind of left with a question, well, how does chance explain something?
Correct me if I'm wrong, but wasn't your entire argument against the physical necessity the fact that the chances were so low? So I'm curious, like, how you go from that to saying that, well, chance isn't actually really a thing and has no descriptive power.
So when I presented this is not chance. These things are finely tuned. And if any one of them changed, you wouldn't have a universe. I would argue they didn't all get these values by chance. They were intentional. Now, the physical necessity argument doesn't rely on chance. The physical necessity argument says it had to be this way, so it's like 100%. There's no chance because the universe had to be this way, meaning it's 100%, not 0 or even 5%. So the physical necessity doesn't involve chance. Physical necessity argument is it must be this way. We must have a universe the way we do.
That's not the argument that I'm familiar with.
Okay, well, we can talk later, but this is the physical necessity. Like, it must necessarily be this way.
In order for this universe to exist.
Correct.
Yeah, so that would be the end to that sentence. It isn't saying that the universe had to be this way in an abstract sense. It's saying that the fact that this universe that we do have is the way it is, is due to the fact that the constants are the way that they are.
Right.
And that they couldn't be different because then this universe would be different. That's the physical necessity argument. Not some idea that the universe had to have been created in a specific way. You're flipping the tautology.
So in this case, what I'm looking at, I'm talking about our universe. Yeah, I'm looking at our universe. And I'm saying, did our universe have to be this way? Now, maybe there's other universes that didn't have to be this way, but we have no evidence for those. But I'm looking at our current universe, right? Yeah, Tom.
I was just going to say that physical necessity argument sounds a lot like that steady state theory, like it was always this way.
Yeah, right. And we know that's not the case anymore. At least the evidence strongly points against that. Right.
And also the chance argument.
Yeah.
Because things just naturally flow, and it's got a name, I can't remember.
Oh, entropy.
Yeah.
Yeah.
Things flow from order to disorder.
Yep.
Just naturally.
Right.
So it's like the chance thing. And
Yeah, but
it just doesn't fit
yeah, but the law of entropy is not random.
Yeah.
It's a law of entropy. Right? It's a physical law, and so it's not chance. It's not random. Right. So yes, it's like the law of gravity. Law of gravity is not random. Law of gravity behaves the same way everywhere we go. So yeah, exactly. So it's hard to think of chance as a causal explanation. Yeah.
And if we're thinking in like the aspect of God, we can think of God being the constant thing
Yep.
And there is variables to that. But he, at the end of the day, those principles have to be in order for anything to work.
Yeah.
But yeah, like we do have free will, but he knows how it's going to be, and it's going to have to fit this, that he knows.
Yeah. I mean, again, we're talking about human agency is something different than these physical constants, right? Yeah. So, but yeah.
What evidence do we have that these astronomical constants are not interdependent?
They are interdependent.
So does that weaken the argument that the odds are so great that
Like for example, here's E. Here's C. Here's the speed of light. Speed of light shows up everywhere, right? Mass of an electron, right? So they are interdependent. So if we were to change one of them by a tiny little bit, a bunch of these other ones would all change as well. It would completely throw off Planck's constant, Faraday's constant, the magnetic constant. So yeah, they are all intimately balanced. So I don't know if that improves the argument or not, but it is what it is.
I think I misspoke. I meant, how do we have any evidence that there wasn't just one constant, say, that set all the others into motion for being correct for human life?
No, not that I'm aware of. They were all discovered independently, but as they were discovered, some of them, like for example, some of these were derived or discovered based on other ones, based on other constants. But I'm not aware of a single, I mean, I'll say this, perhaps the only one you could say that about would be the speed of light, maybe. But even then, there are a lot of constants that don't involve the speed of light, like Avogadro's number. Avogadro's number doesn't matter what the speed of light is, right? So, yeah, I don't know that there's one constant that dictates all the other ones. They all are what they are, and they're all unchanging, and they're not a function of the natural world. They describe the natural world, but they're not a function of it, which it's just bizarre to think that. But yeah, it's interesting. Really interesting. Okay, questions? Any other questions? Yeah.
So I'm having trouble understanding when you're saying chance can't be a cause for something like that.
Right.
Roll a dice.
Yep.
Obviously, like the actual scientific things, the air, the friction, things like that are going to determine it. But I would say by chance it was this number, meaning because of the way things lined up, this is what it is, and 1 out of 6 times it's going to be that number.
Right. I know, and so we use the word chance incorrectly in the English language because there are explanations for why when you roll a dice, this time you get craps and this time you get 12. And it's a function of many, many, many complex variables, wind speed, air temperature, friction. But we can't think about all that, so we just say it's chance. But it's really not chance. Chance really isn't a thing. It's not a causal factor. So, but we use the word incorrectly in our language. We use it to describe things that we just can't explain in a complex way. But it's in and of itself, it's not really a factor.
So then kind of applying it to that same concept.
Right.
You're saying all these constants have to be what they are.
Yep.
All these have to be what they are, sort of thing. Would it be a cause then that in the same way if I roll a dice, if all of these line up, then this happens? Is it you could use, maybe chance isn't the word then to use for that argument for existence, but maybe it's a tiny, and like something that may not be plausible,
right,
quote,
right.
But is it, when you're using that argument then, if you're saying chance can't be a cause for something, is that argument then, but because of the way things lined up, they are what they are? I guess I'm just trying to figure out if, because you can say chance or not, but if all of these happen, then this happens.
Right. Yeah, I mean, so if all of these constants look like this, we get a universe.
Right.
that we live in. And if any one of them is just slightly different, we don't get a universe. Is that chance? Would you call that chance?
I guess it depends on how we're using chance, because I'm confused as to what you're saying chance is.
Yeah, I mean, I'm probably not using it correctly myself because I'm using it the way we use it in a colloquial sense. But what we would say is it's not random and it's not just luck that all of these wound up the way they did. We would say it was intentional, that there's intentionality here. Right? That's how I would look at it. And if any one of them were slightly different, we wouldn't have a universe to talk about. But yeah, I agree. We don't use the word chance correctly in our vernacular, the way we use it, because it really doesn't. In fact, I think, if I'm not mistaken, if you look up the definition of the word chance, it even says something to the effect of without an explanation or without a cause. If you actually look up the word, which then would say it can't have any explanatory power if it can't cause anything. It might describe something, but it can't cause anything. But I agree with you. We use the word incorrectly in our language, for sure. We definitely do. We don't use it the right way. But I don't know. Somebody look it up. What does it say? What's the definition for chance? Anybody have it? No? Nobody have a definition? I'm just curious. What like if you looked it up in like dictionary, on a dictionary app, what is it? What's the actual definition for chance?
I mean, there's different ones. For the noun, there's a possibility of something happening, the probability of something happening,
Okay.
and an opportunity to do or achieve something. And then two is the occurrence and development of events in the absence of any obvious design.
Ah, okay. So they would say, but they wouldn't call it a cause. Is the word cause in there anywhere?
The word chance is not used to describe the underlying thing that's occurring. It's used to describe the information that one has available when making a judgment.
Okay.
When you say the chances of this happening, you're saying based on what I can know.
Okay.
This is what I believe the chances to be, or the most likely outcome to be.
Right.
You're not actually describing what's occurring under the hood, so to speak.
Okay, I would agree. I would agree with that. Yeah. And for that reason, I'd say it's not a cause. It's not causing anything. Yeah, I would agree with that definition. Yeah, I would agree with that. But like I say, sometimes we use the word incorrectly. Actually, a lot of times we use the word incorrectly. Okay, all right. I don't want to keep you too much longer. Any other questions? Any other comments? So who's next week, Rianza? I didn't remember your slide. Who's next? Who's next week's speaker? Okay. All right. Okay. All right. All right. Thanks for coming, everybody. Appreciate it. Oh, I got a microphone here.